just glimpse about what we have seen last lecture. See, we have started with actually our syllabus content. In that, we have seen what is a fiber, what is a yarn, then fabric, then different type of the fabrics we have seen. Hmm, that point we have seen. Now, next point that we are going to study, that is nothing but the degree of polymerization. It is there. Now, I think little bit you have studied regarding the degree of polymerization in a 12th, as well as you have studied in organic chemistry also. Or you might be heard this term degree of polymerization or short form which is used, that is the DP. That DP is nothing but the degree of polymerization. It is there. Now, before going to this degree of polymerization, first see how we are going to see. We are going to come to the what is a polymerization. Before the polymerization, we will see what is a polymer and how we are going to get the polymer. That we will see from the monomer. It is there. So first term, that is nothing but the monomer. It is there. So monomer is an atom or small molecule that may bind chemicals to other monomer to form the polymer. It is there. See monomer, it might be a atom or small molecule that may bind chemically to each monomer to form a polymer. It is there. Now, for example, if you take into consideration, I'll give the two different type of the examples, different monomers. Now, see, monomer might be same or the may not be same. Hmm? For example, when you are considering the addition polymerization, in case of the addition polymerization, whatever the monomer which is used, or we'll take the example of the or polyethylene, simple example. That's CS2 which we got in a repeating unit, that will take. Now here ethylene is our monomer. So CS2 double bond CS2, that ethylene will be our monomer will be there. Hmm? And whatever this ethylene it is there, see this ethylene will undergo addition polymerization. Now ethylene is a unsaturated monomer. Hmm? So it will undergo addition polymerization. And because of the addition polymerization, whatever the polymer which you are going to get, that polymer will be the linear polymer will be there. Now, in few cases, we will get the branch also, but depends on what type of the monomer it is. Now, whatever this ethylene it is there, and as it is going to follow the addition polymerization, so requirement for the addition polymerization, that whatever the monomer it is there, see, monomer is a unsaturated monomer is required. Whenever there is unsaturation it is there, then only it will follow the addition polymerization. Now, in addition polymerization, there are different steps are there, just like initiation, propagation, termination, all this. In detail, you are going to study in a polymer science. Degree of polymerization at these points, you will study in detail in a polymer science. And whatever the polymer you are going to get, that will be the linear polymer will be there. Or as I told you, in few cases, depending upon the monomer, we might get a branch polymer also. Second, that is nothing but the monomer, that different type, or there are few monomers are there where we got a functional group also. So like that molecules, which will get bind chemically. For example, you will take example of the polyester. Now polyester we can manufacture by using the our condensation polymerization. Means in condensation polymerization requirement is that we need to have the two different monomers. Two monomers are required. Now that monomer might be same or the different type it is there. Now in case of the polyester, whatever the monomer which you are using, that monomer we got the terephthalic acid, we got the monoethylene glycol. Hmm? Monoethylene glycol. I'll just show you the structure so that it will be clear to you. Monoethylene glycol. So this is a monoethylene glycol. Hmm? So this is one raw material, and terephthalic acid. And this is our terephthalate acid is there. And this is the benzene ring to which we got the attached carboxyl group. Now here you can see whatever these are the two monomers, and one more requirement that monomer must be a bifunctional. Bifunctional means two functional groups are there. Now this bifunctional means again this functional group might be same or the different, but it undergo the condensation reaction by elimination of the water molecule. We'll get a polymer over here. Hmm? And we are going to get the ester group, and that is nothing but our polyester it is there. So this is a whatever the ethylene is over here, monoethylene glycol, terephthalic acid, they are nothing but the monomer it is there. Now, whenever we are going to get this monomer will undergo the polymerization reaction. Now, as I told that ethylene will undergo the addition polymerization, and whatever this monoethylene glycol and terephthalic acid, it will undergo the our condensation polymerization. Hmm. Now, in case of condensation polymerization, whatever the monomers are there, these are the two different type of the monomers that is required. Second, whatever the monomers are there, this monomers must be a bifunctional monomer. And third, there will be the liberation of the small byproducts. In this case, addition polymerization, you will not get any byproduct. But here, in case of the condensation polymerization, you will get the byproduct. Just like water or any other it is there, we will get the methanol also. Just like small byproduct we are going to get. And they are following the uh, polymerization reaction. So whatever the after the polymerization reaction is over, whatever the things which you are going to get, that is called a polymer. So polymer is a large molecule or macromolecule composed of repeating structure unit, and these subunits are typically connected by the covalent chemical bond. So whatever the bond which is present over there, that will be the covalent bond. And whenever the ethylene is undergoing the reaction, so there are three steps are there. We will not go to details. Just to show you that continuously methyl group will get joined to each other, CS2, CS2, everywhere we are going to get it. So this is one molecule. This is our second one. Mhm. Likewise, this will be the repeating unit will be there. Hmm. And continuously depending upon how much molecular weight is want, we need to stop the reaction at the end, and that whatever the things which are going to get, that is nothing but the polymer it is there. Now in between these also there are few things we are going to get. Monomer, when these two monomers they are coming together, we are going to get a dimer. If three are coming together, we are going to get a trimer. And likewise, if you are going to get multiple, now it is in the range of 8 to 10, hmm, then that is called that oligomers. So oligomers are nothing but the low molecular weight polymers, and it is creating the problem during the processing also. Hmm. How it is creating the process? We are going to get the oligomers and all these things we'll study while studying the synthetic fiber. Hmm. And later on, when you are going to the continuous chain, it is there that is called a polymer. Now, whenever you are talking regarding this monomer, polymer, it is there. Now, monomer will be there in a natural fiber also. Monomer will be there in a synthetic fiber also. Right now, whatever which I have shown you, that is a synthetic one it is there. But in case of the natural fiber, for example, in case of the cotton, whatever the beta glucosinic unit, that will be our monomer it is there. And continuous chain of the polymer which you are going to get, that is called continuous chain of the beta glucosinic unit when we are going to get, that is a polymer, and we are using the term as a cellulose over there. Hmm? So that the thing it is there. If you take into consideration the case with the wool fiber, or you can say the wool and the silk fiber, that is a CONSCHR, that is a repeating unit which we got it over there, and there are different type of the groups are attached. Now to wool and the silk, instead of using the term polymer, we are using the another term that is nothing but the macromolecule. Because in case of the macromolecule, there is no any definite repeating unit. Just like in this case, say in case of the synthetic fiber, we are going to get the definite repeating unit. Here we will get the definite repeating unit. But in case of the wool and the silk, we will not get the definite repeating unit. Why? Because whatever the CONSCHR, CONA, that is nothing but our amide group, it is there. CHR, this R is nothing but a different type of the amino acids are present in wool and the silk. And this R will get randomly attached. We don't know because these are the natural things are there. Which group will get attached over there. There are different 18 type of the amino acids are there. And we don't know which amino acid will get attached over there. So based on this thing, wool and silk, we have to regard as a macromolecule rather than the polymer. It is a polymer, but we got the separate term that is called as macromolecule. And these are the, so what are the, our cotton is there, wool is, whatever our polyester is there, nylon is there. Sorry, nylon is there. All these things, they are coming under the category of polymer. It is there. Now, whatever the reaction which is taking place between the monomer, that reaction we have to use the term as a polymerization. So transition of the low molecular weight constitute, that is nothing but the monomer, into the high molecular weight constitute, that is a polymer via the chemical reaction, that is called as polymerization. Now, whenever you are talking regarding the polymer, again, as I told that we got the linear, means like this polymer chain, it is there. Branch one means a continuous polymer chain, it is there. And to this other groups, if get attached, it is there. That is called as branch polymer, it is there. Then we got the cross link. It is, I think you might be heard the term that is urea formaldehyde resin. That is actually the cross linking, it is there. Network type, just like a rubber, it is there. Or we can use again melamine formaldehyde or DMDHEU resin. They will give us the network type of the polymer. Because of the cross linking, we are going to get a big network structure. So likewise, different type of the polymer structures we are going to get: linear polymer, branch polymer, cross-link polymer, network polymer. And all these things, whatever just now I told you, a linear, branch, cross-link, network, in detail, as I told that you are going to study in the polymer science. Clear the thing regarding this point? Yes?
Yes, sir.
In it,
Yes,
okay.
sir.
Okay. Now next thing, that is nothing but the macromolecule. So molecule which consists of one or of several type of the atoms of the groups of the atom chemically linked into the long chain or the network, that is nothing but the macromolecule. And as I told that the example is a wool fiber or the silk fiber. And repeating unit, I told you CONHCHR or CHNS. So this is one end group. And this is whatever R. As I told that this R is nothing but the 18 different type of the amino acids are there in case of the wool. And there are 12 different type of the amino acids are there in case of the silk. And these are, see, out of the 18 which we don't know which will get attached. So likewise, see here what we are going to get: CONSCH, 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 and this R it is there. This R will be a different type of the amino acid. That's why to the wool and the silk you have to use the term as a macromolecule. Next, I told you the one more term, that is nothing but the oligomer. So an oligomer is a molecule that consists of the few monomer units in a contrast to a polymer that, and at least in a principle, consists of the unlimited number of monomers. Means in a oligomers, what we got? Few monomers units, whereas in case of the polymer, we got the unlimited number of monomers. So oligomers are nothing but the low molecular weight polymers. It is there. So during when you are going to the synthetic fiber manufacturing stage, there is a chances of the formation of the oligomer. Almost near about 2 to 3% we are going to get the oligomers over there. And these oligomers create the problem during the dyeing process. Because when you are carrying out the dyeing, during dyeing process, these oligomers will come out from the fiber. And later on, when you are carrying out the, after the dyeing is over, this whatever the oligomers are there, they will get deposited onto the surface of the fabric, which causes us the use of the harsh feel, dull color, means whatever the shade it is there, what the shade of the dyed fabric that is a dull it is there. That's why to remove this, we need to carry out an operation that is called as the reduction clearing. So that whatever this low molecular weight polymers are there or the oligomers are there, it will get wash out and we'll get a true shade over there. Hmm. So this is unrequired part during the our polymerization reaction. Now then next we are coming toward this our degree of polymerization. Now what does it means? So degree of polymerization is defined as number of monomer units in a macromolecule or polymer or oligomer molecule. Hmm. Now for example, if you see over here, this is a monomer. So here dimer means DP is 2. Here 1, 2, 3, 4 means DP is 4. Here 1, 2, 3, 4, 5, 6 DP is 6. Means what does it mean? Degree of polymerization means the degree of polymerization is a definite number of monomeric units in a macromolecule or polymer or oligomer molecule. That is nothing but our degree of polymerization. And because in a reality polymer consists of the chains of the different length, the average value is used. Now see, whenever you are carrying out the manufacturing, it is not necessary that always we will get the DP 10 fixed out there. For example, 1000 DP. All whatever the polymeric chains will not get exactly 1000 DP. For example, suppose over here 6 it is there. Which whatever the all polymer which you are going to get, this all polymer will not have the same numbers. That number may be larger. Instead of 6, we might get the 8, 10. Instead of getting the 6, we might get the 4, 5 also. So generally when we are going to take, we have to take the average value. So it is always written dp bar. Hmm? Now whenever there is a bar it is there, it means that that is a average degree of polymerization it is there. Hmm? And it is denoted by either we can show the dp bar, xn, xw. Now what does it mean? So dp bar means average molecular weight of the polymer or molecular weight of the repeating unit. That is nothing but the dp bar. Xn means number of molecular weight of the polymer. So here number of molecular weight we have to take into consideration, and xw here you have to take into consideration the molecular weight of the polymer to that of the molecular weight of the repeating unit. Now repeating unit is nothing but the, I will show you the thing here. In this case, this is our repeating unit, cs2 cs2 cn, and whatever the, suppose here we got the 1000. Hmm? Then you have to calculate the molecular weight of this 1000 such type of the repeating unit divided by molecular weight of this repeating unit, which is denoted by xw. Here with the number, see number of molecular weight of the repeating polymer. For example, here number of molecular weight. If you take into consideration the 1000 into molecular weight, whatever it is there, 10 it is there. So 10,000 divided by molecular weight of this repeating unit. Repeating unit molecular weight again it is a, suppose for example 100. So 10,000 divided by 100, whatever you are going to get, that will be our number of molecular weight of the means xn bar it is there. XW means based on to the weight of the polymer. And here we have to average molecular weight of the polymer divided by molecular weight of the repeating unit. So everywhere if you see over here dp bar, xn bar, xw bar, it is divided by molecular weight of the repeating unit. Hmm? Where dp bar is nothing but average degree of polymerization, which is the most commonly used term. Xn bar, number average degree of polymerization, and xw means weight average degree of polymerization. Hmm? Clear the things? Yes. Is
Yes,
it
sir.
clear? Okay.
Yes, sir.
Then next, these are the values of few fibers. Sorry. Degree of polymerization. Cotton degree of polymerization is in the range of 2000 to 5000. Viscose rayon degree of polymerization is in the range of 300 to 400, or in few books you will get 250 to 400 also. Polynesic, it is around 700 to 1100. So all these are the cellulosic fiber. Now from the degree of polymerization you will come to know that, see, viscose rayon got a very less degree of polymerization. Polylogic one little bit higher, that is near about 700 to 1100. Cotton got 2000 to 5000. Now if you compare this, only cellulosic, cotton got the good strength, then polylogic, then viscose. Next, related to the, we cannot compare this fiber with this molecular weight, degree of polymerization. I am comparing only with the cellulosics one because they got the same type of the repeating unit. That's why we can compare it is there. Because beta glucosinic unit is a repeating, it is there in all this. Next, cellulose acetate, degree of polymerization is 225 to 240. Cellulose triacetate, it is around 250. Wool got the 300 to 400 degree of polymerization. Silk 250 to 300. Polyester, it is 100 to 150. Nylon, that is a 6, nylon 6 specifically, that we got the 200 to 300. Nylon 66, 300 to 500. And acrylic fiber, it is around 2000, it is there. So these are the values of degree of polymerization of the various fibers. Now, based on this, what type of the question will be there? Write down the degree of polymerization of the cotton fiber, or write down the degree of polymerization of the any 5 fibers. Likewise, the question will be there. So clear the point regarding degree of polymerization?
Yes, sir.
Okay. Now, one task for you, guys. Hmm. Okay. On your screen now, can you see the poll? There's one question is there. Can you see the
No,
question?
No, sir.
no,
No
sir.
question.
No.
No, sir. No, sir.
No, sir.
Okay, I got it.
No, sir.
I got the answer. Just wait, I will put one more time. So on your screen, there is no any question.
No, sir.
No, sir.
Got, if one of the students tell me that's okay. I created one poll for you, so I can see over here. Can you just check the post in your chapter?
In chat box.
Not in the chat box, in a channel. But this is what I'm doing always. And now just check. I will just post it. Now you can check it. Now can you see? There's one form is there. Sorry. I have created in a wrong team. That's why you are not in a position to see. Now you will be in a position to see.
Yes, sir.
Now can you see?
Yes.
Now just check what you can see.
DP of Woolies.
Now you have to give the answer. There are three options are there. Out of these three, you have to give the answer.
200 to 300.
No, you have to not orally. Or I'll create one more. Instead of that, you can give the answer to that.
सर कुठे दिसेना
Yes, sir.
झालं ते
Disanar
Question
Sir,
झालं?
कुठे
where
दिसतंय?
it is?
Sir, दिसत नाही.
Okay,
Not visible, sir.
okay,
Yes,
leave
sir.
it.
नेमकं कुठे आहे ते सांगताय का जरा?
Leave it. I don't want to waste the time. Okay, we'll continue with the chapter. Okay, only one student was in a position to check the answer. So it is better to stop. हा भेटलं
ते
ठीक आहे आता.
प्रॅक्टिकलच्या स्लॉट मध्ये होतं.
हा ते प्रॅक्टिकलच्या स्लॉटला गेलं ते एकाच बॅचच्या स्टोरना झालं ते म्हणून मी ते कट केलं. ओके हा सो नाउ द पॉइंट रिलेटेड टू द डिग्री ऑफ पॉलिमरायझेशन इज क्लियर टू यू. That's what I told you. I was select that post the poll in a wrong team. So the point related to the DP is clear. Okay, now next point that we are going to see. Am I audible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
होय.
Okay, now next point that we are going to see cohesive energy density. So before going to this cohesive energy density, we must know few things over there. Means what is a cohesive force, what is a adhesive force, and what we are going to get. Okay. Okay, so before going to the cohesive energy density, we must know one thing that is nothing but what is a cohesive force and what is a adhesive force, so that the next point will be clear to us. Now, whenever you are talking regarding the cohesive energy density and how these things will help us. See, cohesive energy density will help us regarding the solubility of the fiber. See, whatever the practical which you are going to perform, that is a identification of fiber. Half of the part we are completed. Now, next point we are going to complete in a practical that is nothing but related to the solubility of the fiber. Now, for example, cotton dissolves in a 70% H2SO4. Now, why cotton dissolves in a 70% H2SO4? Now, its answer lies in a cohesive energy density. So, cohesive energy density. So, before that, cohesive force. So, cohesive force is nothing but it is a force of attraction between the two molecules of the same substance is called as cohesive force. And it is act between the similar substances. Now, for example, the force of attraction between the duster and the bench. So, this is a duster, this is a bench. Now, what does it indicate? Duster, this part, it is made up of wood. Bench, this is also made up of wood. So whatever this cohesive forces it is there, this is a cohesive force that is nothing but the whatever the force of attraction it is there between the duster and the bench it is there, that is called as cohesive force. Means it is a force of attraction between the two molecules of the same substance. It's called as cohesive force, and is act between the similar substances. So bench, that is again made up of wood, and duster, that is also again made up of wood. That's why whatever the force between the bench and the duster it is there, that is called as cohesive force, because these are the two different molecules but of the same substance type, that is a wood. Now cellulosic it is there, that's why they got the force of attraction between this. Next, that is called as adhesive force it is there. So adhesive force, it is the force of attraction between the two molecules of the different substance is called as adhesive force, and it acts between the dissimilar substances. Now example, that is nothing but the wood and the glass. So whatever the wood it is there, and this is the glass is there. Now whatever the force of attraction it is there, that is called as adhesive force it is there. Clear the point? Cohesive force and adhesive force, because for us cohesive force is we need to take into consideration, but we must know what is the adhesive force also. So cohesive force is between the two different substance, same substance type it is there, but of the two different molecules. And adhesive, two different substances also, and two different molecules also. That is nothing but the adhesive force it is there. Now next point that we are going to see, that is nothing but the cohesive energy density. So it is a minimum amount of energy required to dissociate the bond existing between the molecule. What is the definition? It is a minimum amount of energy required to dissociate the bond existing between the molecules. Means, for example, if you take into consideration a cotton fiber. Now in cotton, we got the cellulosic chain over there. So whatever the repeating unit, that is the beta glucosinic unit, it is there. Now in between these monomers, whatever the or the different molecules, whatever the energy it is there. So there must be bonding. Now to break this bond, there must be some energy is required. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Just consider. This is a very important point. Means everything is important. Now just listen carefully. See, there are okay. I'll draw one diagram for you. Suppose this is a bond between the two molecules. Now, what is the cohesive energy density? It is a minimum amount of energy required to dissociate the bond existing between the molecules. So suppose this is a bond between the molecules. Now molecules are different types. So whatever the energy which is required means to break this bond, that energy is nothing but the cohesive energy density. And whatever the minimum quantity which is there, this minimum quantity is nothing but our cohesive energy density. So it is a minimum amount of energy required to dissociate the bond existing between the molecules. And whatever this cohesive energy density it is there, it is directly proportional to the molecular weight of the substance. Higher is the molecular weight, more will be the cohesive energy density will be there. Now, as I told that, for example, in case of the cotton, viscose and polynogic, in which case we got the higher molecular weight in case of the cotton. See, from the DP also will come to know. That's why after the DP, I am going to take this part. If you see the DP of cotton, it is 2000 to 5000, viscose 300 to 400, polynogic 700 to 1100. Means, see, DP is higher means molecular weight is higher, because repeating unit, because all these are the cellulosic fibers. Means whatever the repeating unit it is there, this repeating unit is going to remain same in all these fibers, either in a cotton, viscose, or the polynogic. If you take in all these fibers, we are going to get the same degree of polymerization. Sorry, same repeating unit, because as they are cellulosic. Now, in this case of the cotton, we got the DP in the range of 2000 to 5000. Means it got a high molecular weight. Then moderate, we got the polynergic rayon, and very less we got in a viscous rayon. That's why here I am saying that molecular weight of the substance is directly proportional to the cohesive energy density it is there. And unit for cohesive energy density, it is the calories per mole per 5 angstrom chain length. And this is the energy. That's why we got the calories per mole uh, per 5 angstrom chain length. That is nothing but the distance between this our molecules it is there. So how much energy is required to break down this? That is nothing but the cohesive energy density. And the value for cotton is a 6200. For viscose rayon, we got the 5800. For polynergic rayon, it is in the range of 6000 to 6100. For wool, it is a 9800. Silk also, the value is 9800. For polyester, it is a 7600 to 7800, or around we are using the term as 7800. Nylon 666 both got in the range of 7400 to 7500. Acrylic, it is a 8500 it is there. So this is a CD value of some of the fibers. It is CD value of some of the fibers. In different books, you will get the different values. Now see, whatever the point today which you are studying, that is our cohesive energy density and various degree of polymerization. So you can refer one book. That is nothing but the Polymer Science by Gowarikar. In this book, you will get all these things in detail. Because as these things, see, as our syllabus content is changed, this course was initially for first year it was there, but now it is in a second year same one we got this because of change. Now polymer science also you are studying and this subject. So in both the subject some points are common, but here I am telling you from the fiber point of view, and there you are going to study from the polymer science of view, polymer point of view. No doubt fibers are polymer only, but here we are majorly focusing only on to the fibers. Now, how this, whatever the cohesive energy density it is there, it will help us. Now, definition is clear. Cohesive energy density.
Yes, sir.
Yes, sir.
Ha.
Sir.
Ha. Yes. Any query?
Sir.
Ha. Yes. I'm getting only words, sir, sir. Is there any query? Okay. Ha. I think someone joined just now. That's why it's in the count 62 instead of 61. Okay. Now, how these things will help us? Cohesive energy density. As I told you that cohesive energy density is linked with the solubility of our fibers. It is there. So here we are going to study the cohesive energy density and the solubility parameter that is nothing but the Hildebrand. I think you have studied this equation. Yes or no? Have you seen this equation
Yes.
somewhere?
Yes.
Yes.
Yes, sir.
It is a
Gives energy.
yes. It gives
Energy
not
equation.
only energy. This is a
Gives
someone
free energy.
yes gives
Gives
free
free
energy
energy.
energy equation. It is there. So whatever this gives free energy equation it is there. This gives free energy equation. We are going to use it to link the cohesive energy density and the solubility. It is there. Now see whenever I told you the what does it values indicate means the cohesive energy density of the cotton fiber is 6200 calories per mole per 5 angstrom chain length it is there. Means when you want to dissolve the cotton in a 70% H2SO4, so whatever the 70% H2SO4 it is there, it is supplying that much energy, that is 6200 calories per mole per 5 angstrom chain length to carry out the dissolution of the cotton fiber. And that's why whatever the fiber it is there, it is a dissolving. And it is well proved by the Gibbs free energy equation it is there. So dissolution of an amorphous polymer in a solvent is governed by the free energy of mixing it is there. And it is equation is a delta Gm is equal to delta Hm minus T delta Sm. So delta Gm means gives free energy change on a mixing. That is the energy after the mixing we are going to get. Delta H is a enthalpy change on mixing. T, that is a temperature, that also we have to take into consideration the absolute temperature, because if the temperature is changing, whatever the dissolution parameter or the Gibbs free energy change on the mixing it is there, that is also going to change. Next, delta Sm, that is nothing but the entropy change on a mixing. So can anyone tell me what is a enthalpy and what is a entropy? Yes, any one of you? Enthalpy and entropy. Be fast.
Enthalpy is change in heat energy.
Enthalpy means
Change in heat.
change in
Heat.
okay. Sorry, I'm getting some more answer.
Change in energy for temperature.
It is a change in energy. So enthalpy refers to the total heat content of the system. It is there. That is nothing but the enthalpy. It is there. Now, suppose now I think you have studied this equation. If this value, that is delta H, if it is a positivity there, what does it indicate? If this value is a positive, what does it indicate? It is a endothermic reaction. It is there. And if, this is an endothermic reaction. Endothermic means
Heat absorbing.
it's absorbed.
It is absorbed.
Excellent. Yes, yes, exactly. And if this value is negative means
Exothermic.
that is
Exothermic.
exothermic. Yes, exactly. Whatever the reaction it is there, the exothermic. Now next, what is the entropy?
Entropy is the arrangement of matter.
Disorder.
Yes,
Disorder,
yes,
order.
It is a
Order. Count of
arrangement
order.
of the
Disorder randomness.
yes, it is a yes. Someone is telling so that everyone will listen.
Disorder
It is a
randomness.
it is a related to the disorder or the randomness of the molecules. It is there. So enthalpy is applied to the, it is a sum of the internal energy and the pressure time volume it is there. That is nothing but the entropy it is there. Now these things are clear to you. So next, related to the how the things are related to the solubility it is there. So negative value of the free energy change on mixing means that the mixing process is will occur spontaneously. Now when we will get the negative value, whenever this delta H is when I will get a
Less than
negative,
delta
less than delta S it is
T
there,
at
then
S.
only we'll get yes, exactly. Means our what are the solubilities going on. Otherwise, two or more phases will result in a mixing it is there. Now, for example, suppose I have taken the cotton fiber and I have added the water over there. Does it will get mixed? No. Means whatever the value it is there, this value will be positive in that case. So negative value of the free energy change on the mixing means the mixing processes will occur spontaneously. Means whatever this value it is there, this value must be to have the solubility. Always this value that is change in the enthalpy must be a lower than this. Then only we are going to get this solubility. Otherwise, we are going to get the two different pages. For example, just now I told you that water, and in that we have put the fiber sample. It did not get dissolved over there. But suppose instead of that, I have taken the cotton fiber and I have added a 70% H2SO4 and the temperature is a room temperature. So whatever the fiber it is there, the fiber will get easily solubilized over there. And instead of getting the two different pages, that will be the proper mixing will be there. Mean, since the dissolution of the high molecular weight polymer is always connected with a small or modest increase into the entropy, means in our case, whatever this entropy is there, this entropy must be always higher than this enthalpy. Then only we are going to get the dissolution of the fiber. Otherwise, there will not be any dissolution of the fiber. So the enthalpy term is the deciding factor in determining the sign of the grease-free energy change it is there. And solubility parameters were developed to describe the enthalpy of mixing of simple liquids, just like a non-polar or the non-associated solvent, but have been extended to the polar solvent and the polymers it is there. Hmm? So that is nothing but our cohesive energy density. Now, what type of the question will be there based on this? Now, as I told that, why cotton dissolves in 70% H2SO4? So, answer for this, what you have to supposed to write down? Whatever the cohesive energy. Now, first definition must be there. That cohesive energy density. So, cohesive energy density is nothing but it is a minimum amount of energy required to dissociate the bond existing between the molecules. Whatever the cohesive energy density it is there, it is directly proportional to the molecular weight. Cohesive energy density of the cotton is a 6,200 calories per mole per 5 angstrom chain length, and 70% H2SO4 supplied that much amount of energy to dissociate the bond existing between the molecules of cotton fiber or the cotton fiber polymeric chains, which is supported by our Gibbs theory, Gibbs equation of Gibbs free energy change on mixing equation. And you have to write down this equation. So delta Gm equal to delta Hm minus delta Tsm. M, that might be our fiber or anything material that I have written. So here, to have the proper dissolution of the fiber, whatever this change in the entropy, the change in the entropy must be always higher than the change in the enthalpy. And as this change in the enthalpy is lower and the change in the entropy is higher in case of this dissolution process, we are going to get the complete dissolution of the fiber. We are not going to get the two separate phases over there. So this is the answer. Now suppose we have taken the 40% H2SO4 and our cotton fiber it is there. Now in that case, there will not be any dissolution of the fiber. There will not be any dissolution of the cotton fiber. There will slowly disintegration it is there. So time is there. Means it may take the 1 month or the 2 months, so that slowly the fiber will get disintegrated. Second, suppose now one more parameter I told you, that is nothing but the temperature. Now here, whatever the process which is happening, that dissolution of the cotton in a 70% H2SO, suppose this process is happening at a room temperature. But if I'm going to take the 50% H2SO4 and I got a cotton fiber over there. Now in this case, what I have done? Instead of keeping the room temperature, I have just heated the sample. Now as the temperature is increasing, what will happen? Whatever this thing it is there, that is a T delta S. This thing will go rise. Why? Temperature is increasing. Again, this as the temperature is increasing, whatever the lateral part it is there, this lateral part value will go on increasing and the fiber will get dissolved. That's why though it is written that at the absolute temperature, the process. But if we increase the temperature And even if you got the low entropy value, whatever the fiber it is there, the fiber will get dissolved. So that is the thing regarding the cohesive energy density. Okay.
Yes, sir.
Any doubt regarding this point? See, today we have
No,
studied
sir.
two major points. One that is the degree of polymerization, and second that is nothing but the cohesive energy density.
Yes, sir.
Okay. So what we'll do today, we'll stop here. Next lecture we are going to study one more point that is related to the moisture again and the moisture content of the fiber and classification of the fiber. These 2 points we'll study next lecture. So any doubt regarding this thing? Now the session is open for the discussion.